Hi. So now we'll convert this top-down approach to bottom approach. In the last lecture, I explained you the theory of the bottom-up approach. If you haven't gone through that lecture, please visit that first and then come here. So in the bottom approach, first what we'll do, what is the base condition? First will be our base condition. What is the base condition? If whatever the array is given, if the length of that array is 0, then you need to return 0. Is the base condition. Now I'll create a tabulation base. Because this is a tabulation, you need to create a table, right? That is a 1D table, that is a memo. You will initialize this. Again, the nums dot length plus 1 just to a safer side, and avoid array index out of mod. You initialize this. Now you have a memory. Now the comes as the initialization part. So first two elements we can initialize because we know the value of them. Mem of 0 will be 0. Mem of 1 would be your nums of 1. That's all we have discussed. Nums of 0, because we have just one choice here. If you are standing on the one element, if you are on the one element, you just have one choice, right? That's all. Now again I'll run a loop from I equals to 1 while I is less than num dot length and into I plus plus. What will this loop will do? First you will have the like memo of I plus 1, because you are filling the another element, right, from the previous two element. Is equals to max of, you have two choices, right? First, if you haven't included this, then memo of I. If you included this, then the value, current value. For the current value, we actually need to store the current value somewhere. So you store the current value, right? So the current value plus the amount previous to previous. That is, you are calculating I plus 1, so previous to previous. I know. So now you have memo of I plus 1 calculated, and at the last you just need to return whatever the length, the current index. Current index actually the length. Yeah, so this is our bottom of approach. Let's try this. Yeah, run on the sample. We'll run on the more cases. Again, 100% of the user, this is accepted. Now, like we have discussed the recursive problem, a recursive code, then how to solve that overlapping problem, how to include the memorization and to make it efficient. Then another, that was the top-down approach. Then the second one was the bottom-up approach. This code can further be like memory-wise, speed-wise, time-wise, like we have saved memory. If you take the space complexity of this, right, we have initialize a space of length plus 1, so that is actually order of n. The time complexity, sorry, the space complexity of this code. But if you've seen, you're just using the previous two elements. Like if you have seen, you just to calculate I plus 1, you are just using I and I minus 1. So this can further be improved by using just two variables to store the previous elements, not the whole array. So, okay, I will explain this on the paper, then we'll code this. So in the next lecture, I will explain this two pointer, how to make it more efficient on a paper. Yeah, thanks.